Alrighty, so today we are just going to be practicing more and more of using Pascal's triangle, or in other words, we call that the binomial theorem. So I'm going to go ahead and just underline that and write that underneath because you might see it both ways. Okay, so Pascal's triangle or the binomial theorem. Okay, well, the first thing I want to do is over on this corner, I'm just going to go ahead and give myself that triangle. So we always start with 1, or in other words, anything to the 0 power is just going to give me a 1. Then I go 1, 1, that would be the first power. 1, 2, 1, that would be the second power. 1, 3, 3, 1, that would be third power. And I'm going to go ahead and just put these so we're not getting confused. Fourth power would be 1, 4, 6, 4, 1, and so on and so forth. You could keep finding the rows using that little pattern. You just add up the numbers on top of it, okay? But well, actually, we do have a fifth, so I'm going to go to the fifth, just so we have that. 1, 5, 10, 10, 5, and 1. Okay, perfect. So now that I have my little triangle on the side, I'm going to go ahead and expand. So it says expand the following expressions using Pascal's triangle or the binomial theorem. Okay, well, the first thing we have to identify is what is the power. So for number 1, our power is squared. So that means I would go to my second power row, and I'm going to use the numbers 1, 2, 1. Okay, so I'm just going to write that over here. 1, 2, and 1. Okay, well then underneath these numbers from my pattern, I'm just going to write my terms. My first term is x, so underneath each of these ones, I'm going to do x. And now we need to remember the rule. So with our first term, we're always starting with our highest power and going down to 0. So 2, 1, 0. Okay, then I'm going to do my second term underneath. So it's positive 5, 5, 5, and 5. And these ones are the opposite. So I'm going to start with my lowest power, which is 0, and go up to my highest. 0, 1, 2. Okay, perfect. And now all I have to do from here is simply multiply straight down to find my terms. Okay, so we know that anything to the power of 0 is just 1. 1 times x squared is just going to give me x squared. Okay, well, 5 to the power of 1 is just 5. So 5 times 2 is going to give me a positive 10, and then x to the power of 1 is just x. Again, that's just going to turn into a 1. 1 times 1 times 5 squared, well, this is 25. 5 times 5. 25 times 1 is just positive 25. Okay, and there is our final expression, expanded using Pascal's triangle or the binomial theorem. Beautiful. Alrighty, okay, so let's try that again. And in fact, for number 2, I'm gonna go ahead and skip it. I don't know, we can find the room, that's okay. Okay, so for number 2, I look at my power. This is gonna be 3. Okay, so I go to my third row, 1, 3, 3, 1. The numbers I'm gonna have to use, 1, 3, 3, and 1. Okay, my first term is x, so put that underneath. And start with your highest power and go down. 3, 2, 1, 0. My second term is negative 3, and because there's a little negative, I'm going to put parentheses around it. Negative 3, negative 3. And I'm doing this because when I add my powers, we have to add it so the power is attached to the negative 3, not just the 3 or the negative 1. Okay, so 0, 1, 2, 3. Okay, so now that I have that, I can just multiply straight down to find my final expression. Okay, well, anything to the 0 is just 1. 1 times x cubed is just x cubed. Okay, now this is where the negative comes into play a little bit. So negative 3 to the power of 1 is negative 3. Negative 3 times a positive 3 is going to give me negative 9, and then my x squared. Okay. I'm going to look at my power first. Negative 3 squared actually turns into positive 9. Okay, so 9 times 3 is going to give me positive 27 with my x to the power of 1, or just x. Anything to the power of 0 is just 1. And this is where we need to remember this negative. Okay, so negative 3 to the power of 3 is going to be negative 3, and I'm just going to write this out. Negative 3 times negative 3 times negative 3. Okay, well that would give me positive 9, but then times by negative 3 is what gives me my negative 27. And there we go. There is my final expression. Beautiful. Okay, let's move to number 4. Okay, so I look at my power. It's being taken to the 4th power, so then I find my 4th power row. 1, 4, 6, 4, 1 are the numbers I need to use. 1, 4, 6, 4, and 1. Okay, first term, x, 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 starts with my highest power and goes down. 4, 3, 2, 1, 0. Second term is a negative 2. Again, it's a negative, so I'm going to put these parentheses around it, just telling me that the exponent is attached to the entire negative 2, not just the 2 or the negative 1. Okay, starts low and goes up. 0, 1, 2, 3, 4. Okay, now all I have to do is just multiply straight down. So anything to the power of 0 is just 1. 1 times x to the 4th is just x to the 4th. Negative 2 times 1 is just negative 2. So negative 2 times 4 is negative 8x cubed. Negative 2 squared is going to give me positive 4. 4 times 6 is going to give me positive 24, and then my x squared. Negative 2 cubed, again, remember this is like saying negative 2 times negative 2 times negative 2. Okay, and that is going to give me negative 8. And then negative 8 times positive 4 is going to give me negative 32 with 1x. Okay, negative 2 to the power of 4. Totally forgot to bring a calculator with me, that's okay. Negative 2 times negative 2 would be positive 4 times another negative 2 would be negative 8 times another negative 2 would be positive 16. And then times that 1 and times by another 1. So no x is attached. And there we go. Beautiful. Okay, and let's go ahead. Let's see how I do on number 4 without a calculator. Okay, so my power is 5. So I need to go to my 5th power row. 1, 5, 10, 10, 5, 1. Okay, lots of terms we're going to have here. 1, 5, 10, 10, 5, 1. First term is x, 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 x. Starts with your highest, goes down. 5, 4, 3, 2, 1, 0. Second term is 4, it's positive. So go ahead and just, you don't need the parentheses this time. 4, 4, 4, 4, 4, and 4. Starts low and goes up. 0, 1, 2, 3, 4, and 5. Whew. All right, these are going to be some big numbers that I'm going to have to multiply in my head. That's okay. All righty. So anything to the 0 power is 1. So 1 times x to the 5th is just x to the 5th. 4 times 5 is going to give me positive 20, and then my x to the 4th. 4 squared is 16 times 10 is positive 160 x cubed. Okay, it's kind of getting a little skewed, but I'm on this row right now. Okay, 4 cubed would be 4 times 4 times 4, which is 64, times 10 would be positive 640 x squared. Oh goodness, this is where I really needed a calculator. 4 times 4 times 4 cubed is 64. Okay, hold, give me 1 second. This is so embarrassing that I don't want to do it in my head, but that's okay. So 64 times 4. 256, I should know that. Okay, so that right there is 256, but now I need to multiply that by 5. Okay, so now I take 256 times 5, which I'm just doing on my computer right here. And that is going to give me positive 1,280 with 1x attached. Okay, and my very last row, 4 to the power of 5. Okay, so let's see, 4 to the power of 5 is 1,024. Okay, well, and those are just ones, so we have positive 1,024. And there is my final expression. Woof. Definitely want a calculator. Okay, but that is how you use Pascal's triangle, or in other words, the binomial theorem, to expand these binomials. Okay, so the next thing we have talked about the past couple days is dividing polynomials. Okay, and we talked about using synthetic division to divide these guys. Okay, now there were a couple of rules we had to remember. Okay, in order to use synthetic division with our binomial, okay, our divisor right here, there has to be a coefficient of 1 in front of that first term in order for it to work. Okay, all of these guys have just the coefficient of 1, so this works. Okay, the next thing we had to remember was with that term, that second term in our binomial, what's being divided, you have to change the sign. Okay, so I'm gonna just remind myself that, change the sign on that second term. In other words, this positive 10 is going to turn into negative 10 on the outside. Okay, well now I give myself my little division symbol. And the next thing I do is I just grab the coefficients, okay? The one thing we have to remember here is that our powers go down, or in other words, descending order, meaning 3, 2, power of 1, no v's. Okay, so we're good. We have no spaces to fill. So I can go ahead and just grab these coefficients. I don't want the variables right now. 9, 96, 66, 58. Okay, so now I just follow my pattern with synthetic division. Whatever number is first right there, you just bring it down. Okay, any numbers on the outside here, we're multiplying to this negative 10. So 9 times negative 10 is going to give me negative 90, which goes in this next little spot. When you multiply, it goes in that next spot. Okay, 96 minus 90 gives me positive 6. Okay, again, I'm following this pattern where I multiply these two. 6 times negative 10 is negative 60. Okay, and again, add straight down. 66 minus 60, positive 6. Okay, multiply again, gives me negative 60 again, and add straight down. 58 minus 60 is going to give me negative 2. Okay, so whatever number you get last in this last spot is your remainder. Okay, so in this case, we have a remainder of 2 when we divided these polynomials. Okay, but since we took off our variables to begin with to use synthetic division, we have to put them back on. Okay, but here's the rule we have to remember. If we started with like a third power, you have to go down a power to start. So in other words, this becomes my coefficient of 9v squared because we went down a power, positive 6, v to the power of 1, and then positive 6. Okay, this is what we call the quotient. And again, that negative 2 was the remainder. Perfect. Okay, let's go ahead and try that again. Okay, so coefficient of 1 in this binomial, so that means we can go ahead and use synthetic division. The only thing we have to remember is to just change this sign on that second term, so that positive 2 is going to become negative 2. Give myself the division symbol and grab my coefficients. Again, check 3, 2, 1, 0. We're good. We don't need to fill in any spaces. So remember that this coefficient is 1. So 1, negative 8, negative 10, positive 16. Beautiful. Now we just follow the pattern. Bring down that first number, multiply. Any numbers on bottom get multiplied to go to that next spot. So we get 1 times negative 2 is negative 2. 8 or negative 8 minus 2 more is going to give me negative 10. Okay, negative 10 times a negative 2 is going to give me positive 20 in that next spot. Negative 10 plus 20, positive 10. Multiply, negative 20, and add straight down, negative 4. Okay, so whatever number you get last here, that is your remainder. I'll just label it with an R. We took off our variables to use synthetic, so we took off the x's. We got to put them back off. We just have to drop a power. So it started with 3. We're now going to start with x squared. So 1x squared, or simply x squared, minus 10x plus 10. This right here is our quotient. Negative 4 was our remainder. Beautiful. Okay, let's do it a couple more times. Okay, so we have our binomial here with a coefficient of 1. That's awesome. So we just have to change the sign on that. Negative 2 is going to become positive 2. Okay, put on your coefficients. Remember, this guy is a coefficient of 1. Check 3, 2, 1, 0. No spaces we got to fill. So I have 1, positive 7, negative 19, positive 1. Okay, now follow the pattern. Drop your first number, multiply anything on the outside to get to that next spot. 1 times 2 is 2. 7 plus 2 is 9. 9 times 2 is 18. Negative 19 plus 18 is negative 1. Negative 1 times 2 is negative 2. 1 minus 2 is negative 1. So we have a remainder of negative 1. Took off our variables to begin with, put them back on. Just make sure you drop a power. We started with 3. That means we're going to start with 2 when we put them back on. So 1v squared, or just v squared, plus 9v minus 1. And there's our quotient and our remainder. Beautiful. And let's do our last one. Okay, we're dividing by this polynomial with a leading coefficient of 1, so we're good there. Just make sure you change the sign on the second term. So negative 7 is going to become positive 7. Grab your coefficients, make sure you don't have to fill in any spaces. 3, 2, 1, no x's, so we're good. 4, negative 23, negative 25, negative 71. Okay, go ahead and drop that first number. 4 times 7 is 28. Negative 23 plus 28 is going to give me positive 5. 5 times 7 is 35. Negative 25 plus 35 gives me positive 10. 10 times 7 is positive 70. Negative 71 plus 70 gives me negative 1. Okay, I have a remainder of negative 1. Got to put my x's back on to find my quotient. I just have to drop a power, meaning we started with 3. We're going to start with 2 for our power. So 4x squared plus 5x plus 10. And there's our quotient.